Good morning, everybody. I just wanted to talk to you a little bit today about the assignment. I'm not going to be at school today in the morning, so I'm giving you this assignment and I will have you upload it as an image. You can print it off, it's a PDF, or you can do it in your notebook and upload it. Either way is fine with me. But it is due on Monday, and it's really just a lot of things that we've done in the past. So you're going to have three types of graphs. You're going to have position time, and then you're going to have velocity time, and then you're going to have acceleration time. Now, don't forget that when you look at your position time graph, anything that has a slope that goes in this general direction is positive. And that means that it's going to have a positive direction, and it would have to be graphed up here on your velocity time graph. Anything that has a slope that goes in this general direction would be negative, and because it's negative, its direction is to the left or towards the motion detector, or depending on whatever the situation is, it's just going in a negative direction. So you'd have to graph its velocity below the x-axis. So we have positive velocities, we have negative velocities, and if it's not moving, that would be zero velocity. And then I would like to add to that when you look at your velocity time graph, the slope of this graph, okay, it doesn't really matter where it starts or finishes. It could be a negative slope, in which case you'd have to graph it down here, okay, or it could be a positive slope, in which case you'd have to graph it up here. Okay, now the title of this unit is constant acceleration. So all of our graphs for acceleration versus time are going to be horizontal lines. Okay, we have a positive acceleration, and we have a negative acceleration. We have no acceleration. And whatever the acceleration is based entirely upon the slope from our velocity versus time graph. And if you work backwards, whatever our velocity versus time graph is based on our slope from our position time graph. And so that's today's assignment. Now, just to give you an example, okay, your assignment's going to look something like this. I'm just going to jump over here to number 4, and I'm going to do number 4 with you. I look at the position time graph, and I can see that it has a general positive slope. That means that it is going in a positive direction. And if I look at that slope, the slope is getting greater as time passes. It's curving up, and the slope of a position time graph is velocity. So the velocity is getting greater in a positive direction. I'm going to graph it in the positive region, and I'm going to show the velocity getting greater. Okay, then I look at the slope of this, and it's linear. So that means its slope doesn't change. Slope is constant. We know that the slope of a velocity time graph is the acceleration. So since it has a constant positive acceleration, I'll graph that like this. And that's how you do it. Okay, so there are, I think, 8 or 12 of these, and I would like you to go ahead and do your best and try to complete this worksheet. I've already done one of them for you. Sometimes you are going to have to combine two different things. An object is not necessarily going to have the same motion for the entire time. So sometimes these lines might have a break or a change in the way they're doing things, and so you'd have to piece those two halves together. Okay, one of these is obviously positive and one is negative, so that means we're going to be using both parts of our velocity time graph. Okay, so I'm going to leave you with that. Monday is the day I would like to collect this from you, so I'll make a place for you to post it. Again, you can either print off the PDF, take pictures of it after you're done and upload those, or you can just do these in your notebook, take pictures of them and upload them. But I should have all 12 graphs when you're done. Have a great weekend, guys.